Quadratic binomial. Okay, when you have a 7 by itself, the degree is 0, because remember we said there's an implied x to the 0. The number of terms is 1. The leading coefficient is 7. And we're just going to say it's a constant term. We're not going to say a constant monomial or a constant term. Alright, negative 1/2 x plus 6. The degree is 1 because the highest power on x is 1. The number of terms is 2. The leading coefficient is negative 1/2. And I'm linear because the degree is 1. Binomial because there's 2 terms. Linear binomial. Okay, 5x. The degree is 1 because it's 5 times x to the first power. The number of terms is 1. It's just 5x. It's a monomial. The leading coefficient is 5. And it's a linear because the degree is 1. Monomial because there's 1 term. 10x squared. The degree is 2 because the power on x is 2. The number of terms is 1 because you just have the 10x squared term. The leading coefficient is 10. And the full name is quadratic because the degree is second. Monomial because there's only 1 term. So quadratic monomial is 1 term of the second degree. Alright, we have x to the 4th minus x cubed plus x plus 6. The degree is 4 because the highest power on any term is 4. The number of terms is 4. The leading coefficient is 1 because there's an implied 1 in front of the x to the 4th. And the full name is the degree quartic. Number of terms is 4 terms, so quartic with 4 terms. Alright, negative x to the 5th minus 6x. The degree is 5 because the highest power is 5. The number of terms is 2. There's 2 things being added or subtracted. The leading coefficient is negative 1. And the full term is quintic because the degree is 5. Binomial because there's 2 terms. Negative 10 is very similar to 7. The degree is 0. The number of terms is 1. The leading coefficient is itself negative 10. And we're just going to call it a constant term. And then I have 10x squared plus 6x minus 5. The degree is 2. The number of terms is 3. You're adding 3 things. And the leading coefficient is 10. So it's a quadratic trinomial. And then 6x minus 10, the degree is 1 because there's an implied 1. X is being raised to the first power. The number of terms is 2. And the leading coefficient is 6. Can you figure out what it would be called? First degree things are called linear. First degree things are called linear. There's 2 terms, so linear binomial. All right. I know that was quite a bit, but you actually need to understand how to classify polynomials. It's the equivalent would be knowing the difference between an even and an odd number, a prime or a composite number. It would be a handicap if you went into a math class not knowing what an even number is. You wouldn't be able to understand some of the things the math teacher says. So, like if you don't know what a quadratic trinomial is, you wouldn't be able to understand some of the things your later math teachers will say. So it's a little bit tedious, but it's just a way to classify this new group of mathematical objects. All right. Now, the same way you can add monomials, you can add polynomials. And actually, it's not much difference of a technique. So basically, you just combine like terms in the same way. So problem 3, I have 2 polynomials for you. Negative 6x to the 4th minus 8x cubed plus 3x minus 4. And then the second one is 5x to the 4th plus x cubed plus 2x squared minus 7x. For problem 3, I ask you to add them. And for problem 4, I ask you to subtract them. So for problem 3, you're going to add these 2 polynomials. We're just going to begin by writing out the problem. The reason why I put parentheses around this is to kind of show you that we're adding 2 objects. So I grouped the polynomial with parentheses. But of course, if there's nothing in front of the parentheses, there is an implied 1, right? So I'm going to begin by just distributing or multiply the terms inside the parentheses by 1, which really doesn't change any of the terms. So I'll just rewrite negative 6x to the 4th minus 8x cubed plus 3x minus 4. And then I'm going to do the same thing for the second grouping. I'm going to pretend there's a 1 in front of the parentheses, and I'm going to multiply each term inside the parentheses by 1. And again, we're just practicing for the case when there's something other than 1 in front of the parentheses. And of course, multiplying things by 1 doesn't change them. So what you have here is just a bunch of monomials added or subtracted. The next thing I'm going to do is rearrange the terms to write the like terms together. So negative 6x to the 4th plus 5x to the 4th. I'm adding the quartic terms together. Negative 8x cubed plus x cubed, the cubic terms together. 2x squared is, there's only one squared term, so I'll just write it. Plus 3x minus 7x. I'm adding the linear terms together, and then minus 4. And then I'm going to combine like terms. So negative x to the 4th minus 7x cubed plus 2x squared minus 4x minus 4. Right, negative 6x to the 4th plus 5x to the 4th, negative 6 plus 5 is negative 1, or negative 1 times x to the 4th, negative 8 plus 1 is negative 7. The 2x squared term just stays. 3 minus 7 is negative 4, and then you have the minus 4. And we're just going to state our result at the end. I'm not going to read all that because it's a bit to read, but we added the two polynomials, and this is our result. Our result is also a polynomial. So we added a 4th degree polynomial plus a 4th degree polynomial, and the result was a 4th degree polynomial. Problem 4, I'm going to give you those same two polynomials, and I'm going to add you to subtract the second one from the first one. So we're going to start by writing the problem. The second thing I'm going to do, in order to get rid of the first set of parentheses, you can just drop them because there's nothing in front of them. But to justify just dropping the parentheses, we're going to pretend there's a 1 in front of the first set of parentheses. And of course, if you distribute the 1, multiply the terms inside the parentheses by 1, it just doesn't change them. Now, in order to drop the second set of parentheses, we actually have to do something extra. That negative sign in front of the second set of parentheses means you're multiplying the terms inside the parentheses by negative 1, right? You're subtracting every term inside the parentheses, so the signs have to change. So I'm going to distribute a negative 1. And then when you do that, 5x to the 4th becomes negative 5x to the 4th, x cubed becomes negative x cubed, 2x squared becomes negative 2x squared, and negative 7x becomes positive 7x. And then I'm going to rearrange the terms to write the like terms together. So the 4th degree terms together, the cubic terms together. So there's only one squared term. The linear terms are the 1st degree terms together, and there's only one constant term. And I'm going to combine like terms. Negative 6x to the 4th minus 5x to the 4th is negative 11x to the 4th. I keep the x to the 4th, and negative 6 minus 5 is negative 11. Negative 8x cubed minus x cubed. Remember, there's an implied negative 1 in front of the x cubed, right? So negative 8 plus negative 1 is negative 9x cubed. Negative 2x squared just stays by itself. 3x plus 7x is 10x, and minus 4. Notice the answer is not the same as in problem 3, and the reason is because you've subtracted the second polynomial from the first one, so the answer should be different. It's like the difference between adding and subtracting two numbers. Your result should be different. And then the last thing we're going to do is we're going to just state the result. And again, I'm not going to read this just because it's a bit, but this is what we did. We took a 4th degree polynomial, subtracted another 4th degree polynomial from it, and the result is a 4th degree polynomial. Problem 5, you're asked to subtract polynomials again. This is not much different from problem 4. The only difference is now you have fractions as coefficients, but we're very confident with working with fractions, so we're okay. We're okay with simplifying this. I'm going to start by writing out the problem. 1/2 x squared minus 3x plus 5 minus the whole polynomial 1/3 x squared minus 10x plus 5. Again, you're subtracting two polynomials. This is a quadratic with 3 terms, so a quadratic trinomial. And this is a quadratic with 3 terms, so a quadratic trinomial. You're subtracting one quadratic trinomial from another. We got to get rid of these parentheses. So if there's nothing in front of the parentheses, there's an implied 1. I'm going to multiply the terms inside the parentheses by 1, which of course just means dropping the parentheses without changing anything on the inside, right? Because multiplying terms by 1 doesn't change them. For the second set of parentheses, because there's a minus outside of it, I'm going to multiply the terms inside the parentheses by negative 1. And that, of course, 1/3 x squared becomes negative 1/3 x squared, negative 10x becomes positive 10x, and positive 5 becomes negative 5. So the signs change. All right, so now you just have 6 monomials being added. The next thing I'm going to do is what we've done in the last few examples. Rearrange the terms to write the like terms together. 1/2 x squared minus 1/3 x squared. So the squared terms together, minus 3x plus 10x. The linear terms together, plus 5 minus 5, the constant terms together. All right, and then notice that the quadratic terms have coefficients that are fractions with unlike denominators, right? So I'm going to rewrite the fraction coefficients so that they have the same denominator. The common denominator of 2 and 3 is 6. So 1/2 becomes 3/6, and 1/3 becomes 2/6. So I'm just going to rewrite the previous line, but instead of 1/2 x squared, write 3/6 x squared. And instead of negative 1/3 x squared, write 2/6 x squared, negative 2/6 x squared. And then I'm going to combine like terms. 3/6 x squared minus 2/6 x squared is 1/6 x squared. Negative 3x plus 10x is positive 7x, and then 5 minus 5 is 0. And then I'm just going to simplify. We don't need to write this plus 0. So 1/6 x squared plus 7x. And then, of course, at the end, I'm going to state the result. So subtracting these two polynomials gives you the result of 1/6 x squared plus 7x. All right, and then the last problem, problem 6. We're going to try to tie a little bit of geometry into this, just so you are comfortable with terms like perimeter and area when you go into geometry next year. So problem 6, write a polynomial that represents the perimeter of the shape shown. So you're given a triangle, and its side lengths are not given as numbers. So you're not told this is like 5, this is 7, this is 2. The side lengths are given as polynomials. So the length of this side is 3x plus 5. The length of this side is 3x plus 5. The length of this side is 3x minus 1. Unless you know what x is, you don't know what the number value is, and we're not even given units. So this is just an exercise in algebra and geometry. You're asked to write a polynomial that represents the perimeter. Now, the first thing we're going to do is we're going to try to remember what a perimeter is. Perimeter is the sum of the side lengths of a shape. So it's the simplest geometric measure. You just add the side lengths of a shape. So you have a triangle with 3 sides. So we're going to be adding 3 side lengths. We're going to begin by applying the definition of a perimeter. So perimeter says you add the 3 side lengths. So the first side length is 3x plus 5. So I'm going to write 3x plus 5 plus the second side length is 3x plus 5. So I'm going to write plus 3x plus 5. And then the third side length is 3x minus 1. So I'm going to write plus 3x minus 1. And again, if you have a rectangle, like I gave you a few rectangles on the homework, you would add 4 side lengths. Okay? So this is a version of the answer. This is a polynomial. Now, we know that often we want things in the simplest form possible. So I'm going to try to combine like terms. I have parentheses with nothing but pluses in front of them. So I'm just going to drop the parentheses. I'll multiply the terms inside the parentheses by 1, because if there's nothing outside the parentheses, there's an implied 1. So the perimeter is 3x plus 5 plus 3x plus 5 plus 3x minus 1. Then I'm going to rearrange the terms to write the like terms together. 3x plus 3x plus 3x plus 5 minus 1. And then I'm going to combine like terms. 3x plus 3x plus 3x is 9x. It's not 9x to the third, okay? You're not multiplying the terms, you're adding them. 3 of something plus 3 of something is 6 of that same thing. The thing that you're adding doesn't change. And then 5 plus 5 is 10, minus 1 is 9. So the perimeter of this shape can be represented by a polynomial 9x plus 9. So I'm going to write that the perimeter of the triangle is represented by polynomial 9x plus 9, which is a linear binomial. Linear because the power is 1, binomial because there's 2 terms.